We made it to the last chapter, going towards algebra. And the main idea in algebra is we're using letters like X, Y, A, B, C, any letter, even Greek letters, to stand for numbers. And these letters are called variables. All right, and we just deal with them like we deal with usual numbers, combining them with addition, subtraction, multiplication, division, roots, and powers. And if you make a combination like this, it's called an algebraic expression. So just, here's a very complicated one. We'll look at simpler versions. Okay, so in this algebraic expression, there are two variables, x and y. And there's also some numbers. And you can see the operations here. Well, first this x, there's two things happening to it. It's being raised to the power 2, and then it's being multiplied by 2. This x, we're getting the square root of that x. Okay, and subtractions, additions. There's a division here, this fraction bar. Okay, so at the moment, this algebraic expression, we don't know what x and y are. They're variable, they could stand for any numbers. But then the idea is if I tell you what x is and what y is, then you can substitute those numbers and then work this out. So that's what we look at first, evaluating algebraic expressions. So if you're told what numbers the variables represent, then you can evaluate an algebraic expression. Two basic steps. First step, step A, replace all the variables by the numbers. So you'll be told explicitly which number each letter represents, and then you just substitute. In this step, it's a good idea to use parentheses when you're substituting, and it's essential when you're substituting negative numbers. But you can do it in every case. It's a good habit to get into. It avoids some specific problems. So first step, substitute. Second step, okay, now you just have numbers, and now use the usual order of operations to simplify your answer. So you should be getting a single number. So the whole expression, once you've substituted, you should just be able to get it down to a single number, and that's the answer. That means you've evaluated the expression for those values of the variables. Okay, so all the work we've done with order of operations and in the previous chapters, we're using that again. Example 1, evaluate the expression 2x plus y if x is 5 and y is 3. So this is our algebraic expression. X equals 5, so this we're going to replace this with a 5. Y equals 3. This is going to turn into a 3. All right, so here's the first step, substituting. So I replace x with a 5 in parentheses, and y becomes this 3. All right, what do we have now? Yeah, so now it's just an order of operations question. Yeah, this 2 is multiplying the 5. Here we have addition, but we do multiplication before addition, so it's 2 times 5 first, that's 10, then plus 3, 13. And pointing out here, yeah, this 2x, this 2 is multiplying the x. Yeah, we've seen that before. Okay, so it's definitely, so it's 2 times whatever x is here. X is 5, so that's 2 times 5. Example 2. Evaluate x squared minus 3x plus 6 if, we're looking at three cases. So first case, if x equals 0. Let's do that first. Okay, this is our algebraic expression. The first step, replace those x's with zeros in parentheses. Okay, so we get this. And now remember those order of operations. Yeah, we had parentheses, but nothing to do in the parentheses. So next it's e exponents. So we'll take care of this exponent first. 0 to the power 2, that's just 0 times 0. So that's 0. Exponents, then multiplication and division. Yeah, there is one multiplication. We've got a 3 times 0. That's 0. And then we take care of the additions and subtractions. The subtractions on the left, we'll do that first. 0 minus 0 is 0. And then plus 6 is 6. Okay, so we're just using these 2 steps. Substituting first using parentheses, and then order of operations to get the answer to a single number. Okay, that's the 2 steps to evaluate. Okay, part B. Yeah, so this x is a variable. It emphasizing here that x could be any number. Part B, we're saying x equals 10. So if x is 10, what does this evaluate to? So replacing x's with 10, so we get a 10 squared minus 3 times 10 plus 6. And we're using the same order, so it's 100. And then we get minus 30 plus 6. Okay, then yeah, additions and subtractions left to right. So on the left here we have a subtraction. We'll do that first. 100 minus 30 is 70. Then plus 6, 76. Yeah, so just do these carefully, step by step. Pay attention to any signs. Yeah, so this last case, x equals a negative 4. Yeah, so now it is essential to use parentheses when you're substituting. So this time negative 4 squared minus 3 times negative 4 plus 6. So your first step should definitely look like this. This exponent will work out first. So negative 4 times negative 4 is 16. And yeah, you could see a problem here. So if you didn't use parentheses, if you just wrote negative 4 squared, then it looks like if you write it like this, it means just the 4 is being squared, so that's 16, negative 16. Okay, so you'll get the sign wrong. Okay, but it's really whatever x is. This means x times x. So if x is negative 4, it's negative 4 times negative 4. Okay, so we really need those parentheses. All right, after that we have a multiplication. Yeah, there's two ways to do this. You can do negative 3 times negative 4, that's 12. Or minus 3 times negative 4, so that's minus negative 12, which is plus 12. Either way, it's plus 12 in the middle, and add these up to get 34. All right, yeah, so just an obvious point here is this algebraic expression, you get different numbers coming out. 6, 76, 34. And so different numbers come out if different numbers go in for x. Okay, yeah, we'll talk about functions in a later section. All right, and yeah, we were just substituting whole numbers, but yeah, these x's, yeah, they really can be any number. X could be a fraction, x could be a decimal. Obviously, yeah, it's going to be a bit more work to evaluate these more complicated numbers. All right, so here part A, x is 2/5. So every x gets replaced by 2/5 in parentheses. So it's 2/5 squared minus 3 times 2/5 plus 6. And now we're remembering our work with fractions. 2/5 times 2/5 multiply straight across, that's 4 over 25. We're multiplying here, so write it 3 over 1 times 2 over 5. And I made this a fraction as well. Multiply straight across here. Yeah, the middle piece is negative 6 over 5. And when we're adding and subtracting fractions, we need a common denominator. The least common denominator is 25 for these guys. So yeah, here I've multiplied top and bottom by 5, and here by 25. So that's 4 over 25 minus 30 over 25 plus Yeah, 150 over 25. Yeah, there are different ways to do this. Maybe we could just leave that 6. But okay, so on top it's 4 minus 30 plus 150. Yeah, when you're adding a bunch of sign numbers, you could uh, add the positive ones first. So that's 154, and then minus, or then add negative 30. That's 124. Okay, so we get this answer, yeah, as a mixed number. Uh, 25 goes into 124 4 times, remainder 24, so it's 4 and 24 25ths. Yes, if a fraction or a mixed number gets substituted, yeah, you expect a fraction or a mixed number to come out. This part B, substitute x equals 1.9, so now a decimal. So now we're using our work with decimals from chapter 4. Every x gets replaced by 1.9 in parentheses. So we have 1.9 squared minus 3 times 1.9 plus 6. 1.9 times 1.9. Add the places. So 1 place plus 1 place is 2 places. So the answer should have 2 places. Multiply the whole number pieces. You get 361. And give that 2 places. So 3.61. So that's 1.9 squared. Yeah, 2 squared is 4, so this is a bit less than 4. Next, we'll do the multiplication. 3 times 1.9, yeah, that's 3 times 19 is 57, and give it one place, so 5.7. Okay, again, we'll add the positive numbers together first. That's 9.61, and subtract the 5.7. And remember, our adding and subtracting decimals, just line up the decimal point. And we're getting 3.91. All right, so a decimal went in, and we get a decimal coming out. So yeah, so it's certainly more work when you're substituting a fraction or a decimal, but it's the same idea. Just substitute and then use the correct order of operations. Yeah, the point making the point here that it's very easy to make mistakes if you're substituting negative numbers. Example 4, find a squared minus ab minus b squared when a is negative 3 and b is negative 4. So why don't you try this? So substitute those negative numbers and carefully get it down to figure out the answer. So what is the answer as a single number? Okay, so why don't you try that before I go through it? All right, let's see. So here's the substitution. A is getting replaced by negative 3's. b's turn into negative 4s, and I hope you're using parentheses. Just highlighting the order of operations we need. P parentheses, E exponents and roots, MD multiplication and division left to right, AS addition and subtraction left to right. Yeah, lots of parentheses here, but there's nothing actually to do in the parentheses. They're just single numbers. So again, it's exponents we take care of first. Here I've separated out the two exponent pieces, so negative 3 squared is 9, negative 4 squared is 16. Okay, but yeah, don't lose any minuses, so it's we're subtracting that 16, and there's also a minus here. So make sure nothing gets lost. So it's 9 minus negative 3 times negative 4 minus 16. Yeah, we're multiplying in the middle. Yeah, this AB means A times B. So it's negative 3 times negative 4. And negative times a negative is positive. So this middle piece here we're multiplying next is 12. Yeah, so what's left? Okay, so this turned into a 12, but we're still subtracting that, so it's 9 minus 12 minus 16. Okay, now adding and subtracting sign numbers. Yeah, so if you like, this is 9 minus 12. That's the same as 9 plus negative 12. And I hope you see the answer is negative 3. Then subtract 16. If you like, it's negative 3 plus negative 16. Add the absolute values, keep the sign, so that's negative 19. Okay, did you get that answer? So if you made a mistake, then yeah, check to see you understand. All right. Okay, here we are in the book. So the same thing, yeah, we're looking at algebraic expressions like this. For this example, yeah, so this is more complicated. Evaluate the expression x plus y over x minus y if x is 2 and y is negative 6. Substituting, so each x turns into a negative 2 in parentheses. Each y becomes a negative 6 in parentheses. And yeah, here we get a kind of an awkward case. On the bottom, it's x minus y, and y itself is a negative number, so that's really a minus a negative 6. Yeah, so it's so easy just to write 2 minus 6 on the bottom, but it's really 2 minus negative 6. And we've seen how that works. So subtracting a negative is the same as adding a positive. Keep, change, change. So it's really 2 plus 6, so that's 8 on the bottom. On the top, it's 2 plus negative 6. So adding sign numbers, if you remember, that's negative 4. we have a negative divided by a positive, so the whole thing is negative. And we can cancel 4's, negative 1/2. Okay, so this has a bit of everything. Negative numbers, substituting negative numbers, and then simplifying fractions. Okay, the same algebraic expression, but this time different x's and y's. So now x is negative 3 and y is 3. What happens when you substitute these guys? Well, on the top we have negative 3 plus 3. On the bottom it's negative 3 minus 3. So on the top here we get 0. On the bottom it's negative 6. And then this fraction simplifies to just 0. All right, so the best answer here is 0. Everything disappears. Yeah, we talked about this. This exact example already. Evaluating x squared when x is negative 4, it really means negative 4 times negative 4. So the answer is 16, not negative 16. So use parentheses for safety. So yeah, we're following the order of operations. And yeah, we could be substituting fractions. And this one, the expression is x minus 3y. So if I tell you that x is 4 and y is negative 1/2, well, when you substitute, you get this. So this is just 4. And then over here, it's negative 3 times negative 1/2. Multiplying. So negative times a negative is positive. And then it's 3 over 1 times 1 over 2. That's 3 over 2. Common denominator 2, so this is 4 over 1. So we'll make that 8 over 2. So 11 over 2 is a mixed number, 5 and 1/2. Okay, yeah, some more complicated examples. Yeah, here we have 3 minus, and then in parentheses, p minus r divided by t. Yeah, so these variables can be any letters. In this case, we're substituting fractions, positive and negative. Okay, yeah, so you can see these examples can get complicated, maybe too complicated. So yeah, you can follow through the steps here. So just substitute the fractions and then use the order of operations. Here we have to do what's in the parentheses first. Let's just do one more. How about this? So yeah, this looks complicated. 3x to the third power minus 5x squared plus 13x minus 4. So that's all on the top. Over x squared plus 2. Okay, so this fraction bar means we'll be dividing. we want to evaluate that whole thing when x equals 0. Okay, now, yeah, substituting x equals 0, that's usually a good news. So when x is 0, basically all the x's disappear. Okay, so putting in 0 for x. So each, you can see 0 cubed is 0, 3 times 0 is 0, so this disappears. This also disappears. 13 times 0 is 0. There is a negative 4 left on top. On the bottom, yeah, this 0 squared also disappears. There's just a 2 on the bottom. All right, so this looks complicated, but when x is 0, it's easy. Everything with an x in it disappears, and we're just left with negative 4 over 2. And I hope you see that's negative 2. All right, so let's get into the next section. It's really the same thing, but 6.2, we're using formulas. Formulas are just algebraic expressions for something we want to find. And we've already seen examples. Yeah, we have formulas in geometry. The area of a rectangle, yeah, that's an easy formula. So the area of a rectangle of length L and width W is just L times W. So that's this area inside the rectangle. The length of the perimeter, that's L plus L, so 2L plus W plus W, so 2L plus 2W. The area of a triangle, well, the area of a right angle triangle is A times B divided by 2. Yeah, why are we dividing by 2? Well, the area of this rectangle is A times B, and we just want half of that. And yeah, in general, the area of any triangle, it's just half the base times the height. So B times H divided by 2. All right, so simple formulas for areas. Yeah, you can get areas for things like circles. Yeah, it's slightly more complicated. Example 1, find the area and perimeter of a rectangle with width 1.2 and length 2.6. So using our formula, so we'll substitute 2.6 for L and 1.2 for W. All right, so substituting to get the area and doing this multiplication. Yeah, I did it over here. We need 1 plus 1, that's 2 places, and 26 times 12 is 312. So the area is 3.12. Yeah, no units here. If this was, say, 1.2 feet by 1.2 feet, then the answer would be 3.12 square feet for the area, and feet for the perimeter. Here we're just substituting into the perimeter formula and multiply by 2 and add, so 7.6 units. Here's a more complicated formula. You might have heard of the body mass index, BMI. So you can calculate this to see if someone's has the right kind of weight range, not too heavy, not too light. Okay, so the formula for the BMI, it's usually in kilograms and meters, but here's the imperial version. So let W be the weight of the person in pounds, H the height of the person in inches, and then it's 703 times W divided by H squared. That gives you the BMI. In this example, find the BMI of someone who's 5 feet 10 inches tall and weighs 200 pounds. All right, so are they in the right weight range? Yeah, I think you want the BMI to be less than 25 to be healthy. Okay, so here W is the weight, so that's 200 pounds. We need the height in inches, so convert this just to inches. Every foot is 12 inches. So it's 5 times 12 plus 10, so 70 we need for H. Now substitute. Okay, so we need a 70 squared on the bottom. On the top, it's 703 times 200. Okay, so these are easy to multiply. We can reduce this fraction, so divide top and bottom by 100. So slightly easier, 1406 over 49. And let's convert this into a decimal. So we need 49 into 1406, and I'm adding 0.00. And then just do this division. So 49 goes into 140 2 times. Put the 2 above the 0. 2 times 49 is 98. Subtract. That's 42. And then just keep going and keep bringing down the next number. I added the decimal point here. We're dividing by a whole number, so the decimal point goes here in the answer. Okay, so we're getting 28.69, and we're rounding to the nearest tenth. So if we're rounding to the nearest tenth, here's the rounding place. The next digit 9 is 5 or higher, so we're going to increase this to a 7. So 28.7, that's the BMI. Okay, so yeah, this BMI is above 25, so I would say this person is overweight. All right, so yeah, these formulas, they're calculating something you're interested in. Areas, perimeters, BMIs. So, but it's the same deal. You're just substituting and then evaluating using the correct order of operations. Okay, same formula here. Area of a rectangle. This formula, s equals 16t squared. So what is this for? So this gives the distance in feet that an object falls in a time t, measured in seconds. S equals 16t squared, right? Use the formula to determine the distance an object falls in A, 2 seconds, B, 4 seconds. Okay, so for 2 seconds, then t is 2. So we're getting 16 times 2 squared. So we have to take care of the exponent first. So 2 squared is 4. And then 16 times 4 is 64. All right, so if you drop something and you're high enough up, it's going to fall in 2 seconds. It's going to fall 64 feet. If you drop something and let it, and it can fall for 4 seconds, then it's going to fall. This time 4 squared is 16 times 16 to 56 feet. Okay, so some basic physics here. I guess more physics. So this formula converts temperature in degrees Celsius to temperature in degrees Fahrenheit. So the US, we use Fahrenheit for temperature, but I think the rest of the world uses Celsius. So suppose you're in another country and you see the temperature in Celsius and you want to convert it into maybe Fahrenheit you're used to, then there's a formula to do that. In this example, if the thermometer reads negative 10 degrees Celsius, convert that into Fahrenheit. So maybe you have a thermometer in your freezer, or maybe it's a cold day. Okay, so this is the formula. So we're going to substitute negative 10 for C. And here's the substitution. And then to evaluate this, so it's we're multiplying by a fraction 9 over 5. So we can make this 10 over 1. And it's a positive times a negative, so the whole thing will be negative. So it's negative 9 over 5 times 10 over 1. So yeah, that's just 90 over 5, or even better, cancel those 5s. 10 is 5 times 2. So we're just left with 9 times 2 on top and 1 on the bottom, so 18. Negative 18. Plus 32. Okay, we're adding sign numbers. They have different signs, so subtract the absolute values. 32 minus 18 is 14. Use the sign of the number with a bigger absolute value. That's positive. So the answer is positive 14. All right, so we just worked out that negative 10 degrees Celsius is in Fahrenheit, that's 14 degrees Fahrenheit. All right, so yeah, this is the same temperature, but it's just measured differently. You get different numbers in the Celsius scale than in the Fahrenheit scale. Okay, we'll come back to the Pythagorean theorem in the next section. More triangles. Let's do this last example. Okay, so medical example. The child's dosage for medicine is given by this formula. Yes, A is the adult dosage. T is the child's age in years. Okay, so we're converting an adult dosage to a smaller child's dosage. And this is the formula we're using. Find the dosage for a 4-year-old child if the adult dosage is 48 milligrams. Okay, so for some medicine. So here T is 4 and A is 48. And we're substituting, so those T's become 4s. And we get a 48 here. All right, so yeah, you can see we have a fraction here. So it's 4 over 4 plus 12, and then that fraction is being multiplied by the 48. Okay, so first we'll work on this fraction. So it's 4 over 4 plus 12. And yeah, we have to be careful here. So yeah, certainly these 4s don't cancel. When you have a fraction bar like this, it's really like a grouping symbol. So it means work out the top and the bottom separately. So it's like there's a parenthesis around the top and the bottom. Work them out separately and then do the division. So really, yeah, on the top it's just 4, but on the bottom it's 4 plus 12. So that's 16. Okay, so this whole fraction is 4 over 16. Now we can cancel 4s, so divide by 4 and divide by 4. So we get 1 over 4. Multiplying by 48, a whole number, so that's 48 over 1. So we're getting 48 over 4, which is 12. Okay, so the child's dose of this medicine should be 12, just 12 milligrams. Certainly, yeah, we're expecting a number less than 48, so 48 would be the dose for an adult. So for a 4-year-old child, yeah, it goes down to 12 milligrams. All right, so that's evaluating algebraic expressions and the same thing for formulas.